Okay, we will talk about sniffing technique using DNS poisoning. DNS poisoning is possible using the following techniques: internet DNS spoofing, proxy server DNS poisoning, DNS cache poisoning, intranet DNS spoofing. First DNS poisoning technique. Precondition: the attacker must be connected to the LAN and be able to sniff the traffic or packets. The attacker poisons the router by running ARP spoof or DNS spoof to redirect the DNS requests of client to the attacker's machine. When a client sends a DNS request to the router, here John is the example of a example username of a client. So when a client sends a DNS request to the router, the poisoned router sends the DNS request packet to the attacker's machine. So upon receiving the DNS request, the attacker sends a fake DNS response that redirects the client to a fake website set up by attacker. So next, internet DNS spoofing, second DNS poisoning technique. The attacker sets up a rogue DNS server with a static IP address. Attacker performs internet DNS spoofing with the help of Trojans when the victim's system connect to the internet. This is MITM attack, in which the attacker changes the primary DNS entries of the victim's computer. The attacker replaces the victim's DNS IP address with a fake IP address that resolves to the attacker's system. So here he uses a Trojan to change the DNS IP address inside a victim's system. This is quite simple. Proxy server DNS poisoning. Third DNS poisoning technique. The attacker sets up a proxy server on the, I think this is target system. Sorry, it is attacker system. Correct. The attacker sets up a proxy server on his system. The attacker also configures a rogue DNS and make its IP address a primary DNS entry in the proxy server. So attacker changes the proxy server settings of the victim with the help of a Trojan. So now the proxy serves as a primary DNS and redirects the victim's traffic to the fake website. So in the attacker's machine, first he'll set up a proxy server, um, and then he will configure a rogue DNS, and for that proxy server, he will set the IP address as a primary DNA. So, and then maybe using a Trojan or something, he will change the proxy server setting of the victim so that it will point to attacker's proxy server. Since the proxy server on the attacker machine is pointing to a rogue DNS, so it will direct to the victim's traffic and then to the fake website. DNS cache poisoning. Fourth DNS poisoning technique. The attacker system uses cache memory to hold the recently resolved domain names. Attacker target and makes changes or add entries to this DNA cache, thereby poisoning the DNA. So what happens is DNS servers uses something called as this cache memory. If any client requests for any domain, if the domain is already existing in the cache memory, then it will be easy and it will be fast for the DNS to reply to the client who asked for the domain to IP address. So now since the attacker has changed the contents of the cache memory, it will be the DNS will direct the entries to the attacker's machine. So some of the DNS poisoning tools are derp ns derp nspoof. Derp nspoof is a poisoning tool that assists in spoofing the DNS query packet of a certain IP address or a group of hosts in the network. Using this tool, attackers can create a list of fake DNS records and load it while running the tool to redirect the victim to some other website. How to defend against DNS spoofing? Implement domain name system security extension DNSSEC. DNSSEC is more secure than DNS. Use secure socket layer SSL for securing the traffic. Resolve all DNS queries to a local DNS server. Block DNS requests being sent to external servers. Configure a firewall to restrict external DNS lookup. Implement an intrusion detection system and deploy it correctly. Configure the DNS resolver to use a new random source port for each outgoing query. Restrict the DNS recursing service either full or partial to authorized users. Use DNS non-existing domain NX domain rate limiting. Secure your internal machines. Use static ARP and IP tables. Use SSH encryption. Do not allow outgoing traffic to use UDP port 53 as a default source port. Audit the DNS server regularly to remove vulnerabilities. Use sniffing detection tools. Do not open suspicious files. Always use trusted proxy sites. If a company handles its own resolver, it should be kept private and well protected. Randomize source and destination IP addresses. Randomize query ID. Randomize case in the name request. Use public key infrastructure to protect the server. Maintain a single or specific range of IP addresses to log into the systems. Implement packet filtering for both inbound and outbound traffic. Restrict DNS zone transfers to a limited set of IP addresses. So sniffing tools, Wireshark, Steel Center Packet Analyzer from Riverbed, CAPSA Network Analyze from Colosoft. These are discussed in the iLabs. Packet sniffing tools for mobile iPhones, Sniffer YCAP, Face Sniff. How to defend against sniffing? Restrict physical access to the network media to ensure that a packet sniffer cannot be installed. Use end-to-end encryption to protect confidential information. Uh, Permanently add the MAC address of the gateway to the ARP cache. Use static IP address and ARP tables to prevent attackers from adding spoofed ARP entries for machines in the network. Turn off network identification broadcasts and if possible, restrict the network to authorized users to protect the network from being discovered with sniffing tools. Use IPv6 instead of IPv4 protocol. Use encrypted sessions such as SSI instead of Telnet. Secure copy instead of FTP. Secure copy is popularly known as SCP. And SSL for email connections to protect wireless networks and network users against a sniffing attack. Use HTTPS instead of HTTP to protect usernames and passwords. Use a switch instead of hub as a switch delivers data to the intended recipient only. Always encrypt wireless traffic with strong encryption tools such as WPA and WPA2. Use secure file transfer protocol SFTP instead of FTP for the secure transfer of files. Retrieve the MAC directly from NIC instead of OS. This prevents MAC address spoofing. Use PGP and SMIME, VPN, IPsec, SSL, TLS, Secure Shell, SSH, and one-time passwords (OTPs). Use tools to determine if any NICs are running in promiscuous mode. Use the concept of accept control list ACL to allow access to only a fixed range of trusted IP addresses in a network, change default passwords to complex passwords, avoid broadcasting SSIDs, implement a MAC filtering mechanism on your router, implement network scanning and monitoring tools to detect malicious intrusions, rogue devices, and sniffers connected to the network.